Three adjacent pastures will be built using 32,000 feet of fencing material. So they're going to be built like this. They're next to each other and they're rectangles. Should be a little bit more specific, but that's what it's talking about. Find the length and width of the combined pastures so that the area is a maximum. So you can use X and Y's for length and width. You can use L and W for length and width. It doesn't matter. We'll call this length 1, 2, 3, 4. And then we'll call this width going across the top and the bottom the whole way. So it's find the length and width, so the dimensions to maximize the area and the maximum area. So we learned with all of these area problems, the maximum area always happens when the length and width get the fencing evenly. So if there's 32,000 feet total, half of that's going to go to the length, half of that's going to go to the width. So half of 32,000 is 16,000. So it's split, 16,000, 16,000. 16,000 goes to the two widths, and 16,000 goes to the four lengths. Which means divide by 2, we get the width is 8,000 feet. Divide by 4, the length is 4,000 feet. So that's the shortcut way. You can also just write that the area is length times width, and that the 32,000 feet of fencing is what you get when you add the 2 W's and the 4 L's equals 32,000. There's your two formulas. You substitute one, solve for either L or W. I would probably do W because it's easier to divide. Solve for W, plug it in right there, and then find the vertex. That's the long way. So to find the maximum area, since it's length times width for area, multiply 8,000 times 4,000. And it's really, 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 really big. Make sure you put your units on there for everything.